I wanted to ask one thing that might, again, motivate discussions of the interpretations of quantum mechanics. And I think this might have been my last conversation with Sean. He said that he thinks that the way, or at least one of the most plausible ways to make progress on quantum gravity is to go back to the foundations of quantum mechanics and to get clearer on issues like the measurement problem or many world or spontaneous collapse theories. He didn't actually give those examples, but they're just coming to my mind now. And I'm wondering if this then is not the way that you would go about continuing to work on quantum gravity, which is something clearly that you're doing. So,
I'll try to give you a nuanced answer to this question. So I don't think, personally, that by wildly speculating about modifications of quantum mechanics, I mean, look, first of all, let 1,000 flowers bloom. We all do better as a community by having different people have different intuitions, different career paths, different feelings about what should happen, how it should work. That's how we explore, and that's great. But
right.
For me personally, I don't. Doesn't smell right to me. That doesn't smell right to me. It's too arbitrary, and it's too strongly, for me, founded on an irrational discomfort with quantum mechanics as it presents itself to us. And so I don't think that it has the right markers, the right pointers built into it. I think you're moving away from the truth. But I've given you an example where, by being sloppy about quantum mechanics and the emergence of classical phenomena, we may have gotten ourselves into a lot of trouble. And that's when I talked about the multiverse or any universe in which you have what is called eternal inflation. You have this sort of eternal self-reproduction. It just grows and grows and grows, and different stuff happens in different places. I was complaining that when we describe this kind of thing, we pretend to have definite outcomes happen in different places, when in fact we should be using the spider's description. Remember the spider that has surrounded the galaxy? Everything is happening simultaneously. It's all one big coherent state. And I think that by being careful about that and not making this mistake, we can at least prevent ourselves from, we can do many things. First of all, we'll prevent ourselves from going down a completely wrong road, talking about spacetimes that have just no justification in terms of even arising in a semi-classical limit. It just doesn't make sense. But we can also ask, what does this actually tell us about the regime of validity of our current description of space and time? How confident can we be that we understand this as well as we do? So about 5 years ago, there were some developments in the study of quantum gravity, specifically black holes, that really reinforced my determination to take these things as seriously as I've just advocated we should take them. That development was when we discovered, more precisely, largely through the work of some of my colleagues here, Jeff Pennington and Luca Iliesiu, and a number of other young people, they discovered that this sort of a little bit primitive seeming mix of Einstein's theory of gravity, general relativity, on the one hand, which is classical theory, and quantum field theory, quantum mechanics, that we've been using to describe the world so far, is secretly much better and much more powerful than you might think. Not to say that it's the final answer or anything like that. It's not the quantum theory of gravity. But if you follow the rules, and in particular respect the fact that when you're talking about the whole universe, you can't say that there are observers that happen to not see this or that environment. You've got to just evolve your whole quantum state like the spider would for the galaxy. If you follow those rules, you get extremely powerful results from the theory. In particular, Jeff was able to show that this relatively primitive framework allows you to predict that black holes return quantum information, something that we thought we needed, string theory, very advanced concepts for. If you just ask gravity nicely, it'll tell you that. And it's absolutely critical in that analysis that you don't introduce an environment, that you evolve the quantum state without ever forgetting about any part of the information as it sort of makes its way forward in time in the world. And so I think there is, at that level, there is some interplay between the kind of questions that we grapple with, like how does classicality emerge? Oh, it emerges by forgetting about some part of the quantum state. And our attempts to understand quantum gravity, do black holes return information? Well, in that analysis, we better not forget about part. So I don't have anything to say that's going to really close this loop, but I wanted to point at places where I think there is some contact, like that work about the quantum properties of black holes has certainly reinforced my confidence that we were right in insisting that a quantum description of the whole universe can involve like randomly forgetting about part of the information and then saying, oh, here's my universe, and here's a bubble of new vacuum that forms here and there. It's not a consistent description. It would sort of break a lot of the progress that we've made elsewhere in physics, in addition to never having made much sense to me in the first place.